So now we're going to try and find the derivative of a rational function. And we'll have to use some of the strategies from yesterday when we were finding the slopes of certain functions at certain spots where we had to use common denominators. So we'll have to use that strategy again now to find the derivative of this from first principles. So let's start, as always, with our formula. So the derivative is the limit as h approaches 0 of f at x plus h minus f at x all over h. And so we'll have to add or insert x plus h into this rational function. So the limit as h approaches 0 of 2 over, instead of x plus 3, it's x plus h plus 3 minus just x looks exactly like the function all over h. And it's going to be very tempting to forget about that divide by h because all of our work's going to be on the top and we're doing fractions, so don't forget about that divide by h. Now in the top you see that I have two fractions being multiplied together, or sorry, subtracted, and so in order to subtract them I have to have a common denominator, and the easiest common denominator is the product of them. So we did this yesterday, except they were all numbers. Here there's a bunch of x's. So there is the common denominator that I will need to use in both sides. All right, so equals the limit as h approaches 0. All right, the common denominator then is the product of those denominators. So one of them is x plus h, x plus h plus 3, and the other one is just x plus 3. So that'll be the common denominator I'll need for both fractions, x plus h plus 3 and x plus h. And then as we did before, I'll ask, what did I multiply by this denominator to get this denominator? So the thing I multiplied by was x plus 3, so that has to get multiplied by the top. So the top is 2 times the extra thing that had to get multiplied, which in this case is x plus 3. On the other side, I'll ask the same question. What did I multiply by this? Oops. You see my mistake here. This isn't x plus h, it's x plus 3. What did I multiply by that denominator to get this? And it's this x plus h. So that has to get multiplied up here. So it's 2 times x plus h plus 3. And that whole thing is all just the top of my big limit fraction. All right, so now I'm going to need to do some cleaning up on things. So on the top, I'm going to bring these two fractions together into one common denominator fraction. Since they're common denominators now, I can bring them together and keep the denominators, and then just subtract the numerators. But as I do this, I'm going to do it very carefully. So the first part is 2 times x plus 3. So I'm going to do that little mini rainbow as I'm bringing it together. 2x plus 3. Oh, sorry, not plus 3, because it's being rainbowed by 2. So it's 2x plus 6. Now, the second part. The second part, we are subtracting this rainbow. So I'm going to write the numbers down, but I'm going to show you something here. So it's 2 times x, which is 2x, 2 times h, which is 2h, and 2 times 3, which is 6. Except I am subtracting each of those rainbowed answers. You see that I have this minus here. So I'm subtracting each of those rainbowed answers. You might find it easier to imagine that you're not rainbowing just a 2, but you're rainbowing a negative 2. So when I rainbow the negative 2, it becomes a minus 2x. Technically, I'm just rainbowing the 2, but then I'm subtracting that answer, so it's minus 2x. And then I'm doing 2 times h, which is 2h, but I'm subtracting it, so it's a minus 2. So it feels like I'm rainbowing a negative 2. And finally, 2 times 3 is 6, but I'm subtracting it, so it feels like I did negative 2 times 3 to get 6. So I did 2 steps in one there. I hope that's okay. If you want to see the intermediate step, it would look, the step before that would be the 2x plus 3 over this fraction minus, and then the 2x plus 2h plus 6 all over this thing. But then I'm subtracting each of these things. So when I subtract the 2x, I get this. If I subtract the 2h, I get minus 2h. If I subtract the 6, I get the minus 6. But I think that purple thing kind of makes it a little messy, so I'm going to erase that. And just imagine that I did those steps in one. All right, so let's keep going, because on the top I now have like terms. So limit as h approaches 0. You'll see that I've got a 2x and a minus 2x, and I'm really excited that those are going to cancel. Remember, I hope that anything that doesn't have an h in it is going to disappear. Similarly, I've got 6 and a minus 6. Those are going to cancel. Had I got my signs messed up when I was doing the previous line in one step, something would not cancel. I'd know that I'd make a mistake. But here I've done it properly. So all the x's and the 6's, in fact, anything that doesn't have an h in it, should disappear. So that'll leave me with this negative 2h over this rather unruly denominator, but that's fine. And this whole thing is still at the top of the fraction of that. Remember, I'm not going to actually rainbow this. I don't want to rainbow this thing here. It's just going to make my question harder. And plus later on I'm going to substitute in h equals 0. It'll be easier to substitute in this formula. So just leave the denominator as that kind of big but easier denominator. All right. So things have simplified. Lots of things have disappeared, which is good. And now I am dividing by h. And so I'm going to use the same idea that I did yesterday. When I divide by h, I'm going to multiply by the reciprocal of 1 over h. And by multiplying by 1 over h, I can divide by h's, and I will be left with the limit as h approaches 0 of just negative 2 over this fraction, which is x plus h plus 3 over x plus 3. And since I brought the h up top here, this is just a 1, and 1 times this thing is just the same, and the top is a 1 times negative 2, and that just leaves me with negative 2. And I've successfully gotten rid of the problem h value. Remember, the problem h value is always right here, because if I plugged in 0, I would get a problem. I'd be dividing by 0. Now you might look at this and say, hey, Mr. Lee, I've got a 0 on the bottom of a fraction, which still might be a problem. But you'll notice that that h has lots of things happen to it. So when I plug in 0, I don't think I'm going to end up dividing by 0. So it won't be a problem. I'm now successfully at a spot where I can take the limit or evaluate the limit. I can now actually sub in h equals 0 without fear of my calculator blowing up. So I'm going to do that. -2 on the top, there's no h there. The bottom I got x plus h, but now it's going to be x plus 0 plus 3. There's no h in the second part. X plus 0 plus 3. Well, that looks like x plus 3, x plus 3. And I'm going to simplify that even further. And since I have an x plus 3 times itself, I can write that as x plus 3 squared. And there is the equation for the derivative of that original rational function. -2 over x plus 3 squared. Now, as you do enough of these, you're going to see this bottom thing being squared in a lot of your derivatives. So you see the original function way up here was x plus 3, and the derivative ended up having x plus 3 squared. Because as you do enough of these, you'll see the same pattern happen over and over again. And then we might be able to, in the next unit, predict what that answer is. But right now, we're doing this from first principles. So if you look at the entire solution all together, you'll see that I substituted x plus h in the first line, brought together a common denominator. This meant that the numerators had to be adjusted slightly. I rainbowed and subtracted the second one at the same time. This resulted in a lot of lines canceling out. Anything that didn't have an h in it should cancel. And luckily my 2x and minus 2x canceled, and my 6 and minus 6 canceled. This meant I could then divide by h by multiplying by 1 over h. And it means the h's will cancel each other out, which leaves me with a function that will allow me to substitute 0. The 0 in for h makes the bottom x plus 3 squared, and the top is just -2. And there is my solution for finding the derivative of 2x over x plus 3. So those are all the examples I'm going to show you. There is one with a root sign that I might make another video depending on which year it is. Otherwise, you'll be getting some practice questions from the teacher notes. Thanks very much, and thanks for watching.